Here we have a SAT math problem. Okay, let's go to the question. There is a figure given over here. In the figure above, AB equals to 9, CD equals to 3, and AC equals to 12. What is the length of the line segment PQ over here? Okay, now let me consider the two triangles first. So triangle ABC and triangle QPC. Okay, I consider both the triangles are similar triangles because a triangle ABC contains a right angle over here. Triangle QPC over here also contains right angle, and C is the common angle for both the triangles. By angle similarity postulate, the two triangles, triangle ABC and triangle QPC, are similar. Let me write the stuff over here. Triangle ABC is similar to triangle. So for the vertex A in the bigger triangle, the corresponding vertex in the smaller triangle is Q. Let me write Q. And for B, we have P. And C is the common vertex for both the triangles. So the two triangles are similar. Whenever two triangles are similar, then the corresponding sides are proportional. That is, the ratios between the corresponding sides must be equal. Okay, now let me take the side AB from the first triangle. The corresponding side in the second triangle is QP. Sorry, the letters are the same position, QP. And let me take the side AC in the first triangle. And the corresponding side in the second triangle is QC. Let me write the stuff over here. Okay, we know that, that the length of AC over here is 12 units. I assume the length of QC over here as X. Then what is the length of this AQ? It has to be 12 negative X. Let me write over here. That is, we have to subtract this length from the complete length AC. And also let me assume the length of this line segment PQ as Y. Our aim is to find the length of PQ. That is, we have to get the value of Y. Okay, now let me plug in the length of AB. The length of AB is given over here, that is 9. And the length of QP or PQ, whatever it is Y. It is assumed as Y. Then we can plug in Y for QP. And for AC, for this line segment, we know the length is 12. And for QC, we have assumed X as the length. We can plug in X over here. Okay, now let me solve for Y in this equation. For that, I'm taking reciprocal on both sides. When I take reciprocal for this 9 over Y, I'm getting Y over 9. When I take reciprocal for this 12 over X, I'm getting X over 12. Okay, now to solve for Y, I have to get of this denominator. For that, I multiply both sides by 9. When I do so, this 9 will cancel out. And here both 9 and 12 have the greatest common divisor 3. That is 3 goes into 9 3 times, 3 goes into 12 4 times. I am getting Y equals to 3 times X is 3X. In denominator, we have 4. Okay, now I got the value of Y in terms of X. Once I get the value of X, I can plug in the value of X over here. And I can get the value of Y, which represents the PQ. That's the required length. Okay, now let me consider another pair of similar triangles. That is, let me consider triangle CDA and QPA. So here these two triangles are similar because both the triangles have right angles. So because the triangle CDA has right angle at the vertex C, and the triangle QPA has the right angle at the vertex Q over here. When we have right angle over here, on this side also we have right angle because the angle on the straight line over here 180 degrees. So when this is 90 degrees and this one also must be 90, so that 90 plus 90, 180. Anyways, we have right angle over here. And also A is the common angle for both the triangles, triangle CDA and triangle QPA. So by angle similarity postulate, the two triangles are similar. Okay, now let me write the vertices. First, let me take the vertex of this bigger triangle CDA. So let me take the vertex C. And the corresponding vertex in the smaller triangle is Q because we have a right angle at C and Q. Now let me take the vertex D, and the corresponding vertex in the second triangle is P. And now let me take the common vertex A in both the triangles. So these two triangles are similar. And the same thing, since two triangles are similar, the corresponding sides must be proportional. Let me take the side CD from the first triangle. The corresponding side is QP. Let me write over here. Now let me take the side CA from the first triangle, and the corresponding side in the second triangle is QA. Okay, here you may notice one thing. So here I've taken CD and CA. Why don't I consider DA? Because we don't have any information about the DA, that is the length of DA. In the previous case, in this one also, I don't consider the side AC. I'm sorry, I don't consider the side BC because we don't have any information of BC, I mean the length. Okay, now what we can do is we can plug in the values over here. For CD, we know the length is 3. And for QP, already we have assumed Y as a length. We can plug in Y. And for CA, CA is nothing but AC, it's 12. And for QA, we have 12 negative X. Let me plug in over here. 12 negative X, sorry. Okay, now what I'm going to do is to solve for Y, I'm going to take reciprocal on both sides. Then I'm getting Y over 3 equals to 12 negative x over 12. Okay, now let me multiply both sides of this equation by 3. When I do so, this 3 will cancel out. 3 goes into 3 one time, 3 goes into 12 4 times, and I'm getting y equals to 12 negative x over 4. Okay, here I got the value of y in two ways. So using the triangle ABC and triangle QPC as similar triangles, and triangle CDE and triangle QP as similar triangles. Okay, anyways, this 3x over 4 and this 12 negative x over 4, both of them are the values of y. Since both of them are the values of y, we can equate them and solve for x. So that is 3x over 4 equals to 12 negative x over 4. Okay, now we can multiply both sides of this equation by 4 to get up the denominators on both sides. 4 will cancel out. Here the same thing. I am getting 3x equals to 12 negative x. Okay, now what I can do is I can add x to both sides. When I do so, this negative x positive x will cancel. Then I'm getting 4x equals to 12. Let me continue over here. We get 4x equals to 12. Let me divide both sides by 4. When I do so, this 4 will cancel out. Then I'm getting x equals to 12 over 4 is 3. Okay, now I got the value of x. Now what I'm going to do is I'm going to plug in this value of x3 over here to get the value of y. Let me do it. Y equals to 3 times. You can plug in 3 for x. Then I'm getting 3 times 3 over 4, which is 9 over 4. When I divide 9 by 4, I am getting 2.25. Actually, y represents the length of PQ. Therefore, the length of PQ equals to 2.25.